All right, so are you ready to really level up those Java skills? Like get into the real object-oriented stuff?
Yeah, like how those objects get passed around.
Exactly. It's like it's like learning some secret coding handshake.
Ooh, I like that.
Right. So that's what we're diving into today.
That's good.
We've got some code snippets for you, and we're going to unpack how you pass objects as parameters in Java. And to make it really clear, we're going to use an analogy. Think payment systems like credit cards and PayPal, things like that. You get the idea.
Oh, that's great, because what's cool about that is it's not just some abstract coding idea.
Right.
It's like how things actually work in the real world.
Yeah, it's like the code is suddenly like reflecting the world.
Yeah.
But okay, before we get too philosophical here,
Right.
let's break it down. We're talking parent classes, child classes, inheritance, that whole ISA relationship thing, and then composition, which is more like a Hasse relationship.
And these relationships are really key to understanding how we build complex systems by combining those simpler pieces, just like we do in the real world.
Okay, so picture this. We're building a payment system.
Okay.
You'd probably start with a parent class called like payment.
Right.
And it's kind of like the foundation, you
Yeah.
know, it lays out the blueprint for all your different payment methods.
Exactly. And this payment class would kind of define that basic structure, like a method, maybe we'll call it process payment. And this method would outline the steps for handling any kind of payment.
Okay.
But the parent class itself doesn't actually process anything.
Oh, so it's like delegating, right?
Right. That's where those child classes step in.
Okay, so the parent sets the stage, and then the child classes come in with their specialties.
Exactly. You might have, say, credit card payment and PayPal payment as those child classes,
Uh-huh.
and they inherit from payment. So they share that basic structure,
Okay.
but they add their own little twist on how to actually process those payments.
So it's like everyone starts with the same base recipe, but they add their own little spices to it.
Yeah. Like one might interact with a credit card gateway while the other one works through the PayPal API.
Right, but in this case, it's all about making sure those payments go through, right?
Exactly.
And this is where the ISA relationship comes in.
Uh-huh.
So credit card payment and PayPal payment are children of payment, so we can say that credit card payment, ISA payment,
Right.
and PayPal payment, ISA payment.
Exactly. And this ISA relationship is important because it means we can treat any of those child class objects as if they were instances of that parent class payment.
Okay.
So a variable that's declared as payment, it can actually hold a credit card payment object
Okay.
or a PayPal payment object. It's this flexibility that makes object passing so powerful.
Wait, hold on. So you're saying I can order a payment and I could get a credit card payment or a PayPal payment and it all just works?
Yeah, the system just figures it out. That's the beauty of it. It's all handled seamlessly because of inheritance.
That's cool.
And this leads us to one of the cool parts, passing objects as parameters. Imagine you have a method called process transaction. This method takes a payment object as a parameter,
Uh-huh.
but because of that inheritance we talked about, this one method can handle any type of payment,
Oh, wow.
whether it's credit card payment, PayPal payment, or even some new payment method you come up with later on.
Oh, so I write this one method and then I can just throw anything at it.
Exactly.
It's ready for any payment type?
You got it.
That's efficient. No need to rewrite everything every time you make something new.
Exactly. It's like having this universal payment processor that just adapts to whatever you need.
Okay.
And the key to this adaptability is called dynamic method dispatch.
Okay. Dynamic method dispatch. So what's going on behind the scenes there?
Well, think of it this way. You call that method process transaction, right?
Uh-huh.
And you give it a credit card payment object. The system looks at the actual type of object, so in this case, credit card payment, and then calls the process payment method that's specifically designed for that type.
So it knows which flavor of process payment to use.
Yes, based on what it's given.
That's pretty neat how it just figures it out.
It is. And let's actually take a look at some code.
Okay, yeah, let's bring in the code.
You've got those snippets, right?
I'm ready.
Okay, so this code defines those credit card payment and PayPal payment classes,
Okay.
each with its own way of handling process payment.
Mm-hmm.
And then we have the process transaction method that takes any payment object
Okay.
and then simply calls process payment on it. And then finally, in that main method, we create instances of both those payment types and pass them to process transaction. And the system just knows which process payment to call based on the object's type.
Wow, seeing the code really makes it click, you know? So we create this method that accepts this parent class object. Then we can just throw any of the child class objects at it, and it just knows what to do.
Yep.
This is kind of like a superpower.
It is a powerful tool. And this approach allows for incredibly flexible and reusable code, which is what you need when you're building these complex systems.
Right.
But we've been focusing on inheritance, that ISA relationship.
Yeah, what about composition?
Right, that has how does that fit into all of this?
So composition is like we're building something by combining parts.
Yes. Instead of inheriting, think of a car and an engine.
Okay.
A car has an engine. They're separate things.
Right.
But the car needs the engine to function. In code, we would represent this by having an engine class and a car class. The car class wouldn't inherit from engine, but it would have an instance of the engine class as a member variable.
So it's not about inheriting, it's about having this component as part of the bigger thing.
Exactly.
So we'd have something like my car equals new car with a new engine in the parentheses.
You got it.
To create a car with an engine.
Yes. And then within the car class, we could have a method like start car.
Okay.
And this would essentially say to the engine object, hey, do your thing, run.
So car is like the manager giving orders,
Uh-huh.
but engine is actually doing the work.
Exactly. It's all about delegating tasks.
This is fascinating. We're building systems just like in the real world with different parts working together.
Yes.
But can we combine ISA and HASA?
Oh, absolutely.
Like, could we have a sports car that ISA car,
Yes.
but also has a super powerful engine?
Absolutely. That's where the real power comes in.
Yeah.
By combining inheritance and composition, we can create these incredibly sophisticated systems. Think of it this way, like you're building a racing game.
Oh, okay.
You could have a car class.
Yeah.
That's your parent class,
Right.
defining all those basic car behaviors.
Yeah.
Then you could have sports car, truck, Formula One
Okay.
as child classes,
Mhm.
each inheriting from car, but with their own special things.
Okay, so each of those ISA car,
Yeah.
but they also have their own qualities.
Exactly. And to make things even more interesting,
Okay.
we bring in a separate engine class.
Oh, okay.
Maybe you have V8 engine, electric engine.
Oh, so a sports car could have a V8 engine.
Exactly.
While the Formula One car maybe has a turbocharged engine or something.
Exactly. And you can even have variations
Oh, wow.
within those engine types.
Okay.
Like a supercharged V8 engine.
Right, more power.
More power. You're creating a really rich system.
This is making me want to go dig out my old game development books.
Right.
But okay, let's get back to our payment system for a sec.
Okay.
We talked about the theory, we saw some code, but how does this actually work in a real application?
Well-
Like if we were going to build an e-commerce platform.
Great question. So let's say you're building an online store.
Okay.
You'd have different parts of the system that need to deal with payments.
Uh-huh.
You might have like an order class
Okay.
representing a customer's purchase.
Right.
And that order class would need to be able to process the payment.
So within order, we'd have a method like checkout
Exactly.
that takes a payment object.
You got it. And when the customer hits that place order button,
Uh-huh.
the checkout method does its thing.
Right.
It calls our process transaction method,
Right.
passing in the right payment object, whether it's credit card, PayPal, whatever they picked.
So checkout is like the conductor.
Yes.
It's making sure the whole payment goes through,
That's a great analogy.
no matter the instrument, so to speak.
Exactly. And because process transaction can handle any type of payment object,
Right.
the system just works.
It's amazing how all these things can be broken down into these like manageable pieces.
Uh-huh.
Then you can just keep adding stuff as you go.
Right.
So like what if we wanted to add a loyalty program
Okay.
so customers get points for every purchase they make?
We could create a loyalty program class
Okay.
with methods for awarding points, handling redemptions.
Uh-huh.
Then we could tweak our process transaction method
Okay.
to interact with this loyalty program after a payment is successful.
So it's like, hey, loyalty program, this customer just bought something, give them points.
Precisely. And this would happen no matter what payment method they used.
Wow. The flexibility is really amazing.
It is.
It's like we're building a world where these objects are talking to each other to make things happen.
It is.
What are some other ways these concepts get used?
Well, think about any system where you have different types of things interacting. A transportation system with different vehicles, a banking system with different accounts,
Different types of accounts.
or like a social media platform
Oh, wow.
with users, posts, comments.
It's mind-boggling when you start thinking about it.
It is.
I'm also realizing there's so much more to learn.
Yeah.
Like, what should someone who's starting out look into next?
Well, once you're comfortable with inheritance and composition,
Uh-huh.
you can dive into interfaces and abstract classes.
Mm-hmm.
Interfaces are a way to define a contract that classes can implement,
Okay.
which makes your code more modular and flexible.
Okay.
And then abstract classes let you define a common base for a group of classes.
So interfaces are like setting standards, and abstract classes are like making blueprints.
That's a good way to put it.
Okay.
And then there's the whole world of design
Oh,
patterns.
yeah, I've heard of those.
They're reusable solutions to common problems. A lot of them use object-oriented concepts like inheritance and composition
Okay, cool.
to create really elegant and efficient solutions.
It sounds like a whole universe of stuff to explore.
It is.
It's a bit daunting, but also exciting.
Yeah.
So what advice would you give to someone just starting out?
I would say don't be afraid to experiment.
Okay.
Play with the code, create your own classes and methods,
Mm-hmm.
see how you can apply these concepts to problems that interest you.
Yeah.
The more you practice,
Mm-hmm.
the more comfortable you'll become.
And remember, the best way to learn is by doing. Don't get bogged down in all the theory.
Right.
Just jump in and start building.
Yeah, you learn so much from just trying things out.
That's right. Yeah, it's really amazing how these concepts can apply to like almost anything.
Oh, yeah. Object-oriented programming is like one of the most fundamental ideas in software.
So for our listeners who are like really getting into objects and inheritance and all that,
Uh-huh.
any final words of wisdom?
I would say embrace the process.
It's a journey, right? Not like a destination.
Exactly. And remember, even the most experienced Java developers were once beginners, too.
Yeah, we all start somewhere.
So be patient and have fun, and don't be afraid to ask questions.
There's a huge community out there.
Yeah, lots of people willing to help.
It's great.
It is. Well, I think we've covered a lot today. We've explored passing objects in Java,
Yeah, from inheritance and composition to how it all works in the real world.
and we saw how these ideas make code reusable and flexible.
So you can build some really complex systems.
Yes, and it's really just the beginning
It is.
of your journey into object-oriented programming.
So keep learning, keep building.
And remember, the possibilities are endless.
Happy coding, everybody.